My name is Piotr Prus, and I'm working at Tilt, which is a streaming e-commerce platform for Gen Z. And today I will be talking about managing hundreds of UI updates, and I will be building Emoji Canon for that. So let's blast off. So let's begin with this canon. It will be super simple, just to show you what we'll be doing here. To animate those emojis, to fire them from the bottom of the screen, I will need a starting point and end point. So my starting point will be just taking from configuration. I'm taking the half of the width and then almost 90% of the height. So the starting point will be exactly where the button is. And then my endpoint, also taking from local configuration, I will take the whole width and then 20% of the height. So all my emojis will end somewhere there. And as you can see, all those emojis have some random rotation from minus 90 to 90 degrees, randomly picked. And at the end, after all those changes, I want them to fade out. So I'm waiting for all the animations to finish, and at the end, I'm calling, after awaiting all, I'm calling opacity animatable animate to 0. So all the emojis are disappearing. And how this emoji is rendered, this is just a box with all those properties like offset, rotation, and opacity in it, in the modifier, and then there is just a text with the emoji Unicode that floats on the screen. And I have the data class for every emoji with rotation, offset, and Unicode. And in my composable, whenever I click the fire button, I'm adding one new emoji to the list. And then this list in composable, for each emoji, I'm displaying my single emoji container that have one single emoji on the screen. So that's it. Everything looks good. What could go wrong here? Any guesses? Performance problems, yes. Yes, for sure. So to be exact, we'll check the recomposition count using the layout inspector. And what you would expect here? So let's fire one emoji and check how many recompositions we have there. 278. Let's try another one. Can we go more? 281. Yeah. So our single emoji is recomposing almost 300 times. And why it is happening? We need to managing those recompositions. And I found this article very helpful by Ben Trentgrove, Jetpack Compose debugging recomposition. And this article will guide you through how to manage those recompositions. But basically, we should prefer lambda modifiers when we are using frequent changing states. And why we should prefer them? Because normal modifiers, when we change the value in modifier that is not lambda, the whole modifier tree is recomposed. That's why we have so many recompositions, because every change in the offset or rotation is recomposing the modifier tree. When we are using lambda, it's used during the render time, so it's not causing the recomposition. So let's change that. For the offset, we can use offset lambda and then int offset, and we'll do not have more recompositions for the offset. But for the rotation, we do not have the lambda version. But hopefully, we have the graphic layer. So we can just change the rotation Z here. And for alpha, we are doing the same. We are putting that in the graphic layer. And now all our parameters that are changing frequently are in the lambda. So let's check if that works. So firing one emoji, checking the layout inspector. And as you can see, nothing. We do not have any recomposition. So that's great. Now let's go to some more challenging project. let's fire 10,000 of them. What could happen now? Like, we do not have those recompositions, but we'll still have some performance issue. So we skipped 728 frames. And we have this weird error, delay. By the way, this error comes from name of the VP of Android, Dave, that was filling a lot of bugs. And that's why we have this weird error here, delay. And we can see that our garbage collector is firing, and we are freezing the app for 12 seconds. So let's see what the memory footage from memory profile looks like. You can imagine that we start firing those 10,000 emojis here. We end up there, which is 200 megabytes already. And as you can see, then the graph is flat. So we have some memory issues. As you can see now in this layout inspector again, there are a lot of invisible items. Do you see them clearly? I don't know if it's clear there, but there are those boxes showing that emojis are there. They are not visible because the alpha is 0, but they are still there. So we need to remove them from the list. So easy said than done. So we had this await all to decrease our opacity to 0. So now I will be calling a function on animation finished, and in my single emoji container, I will be just calling from lambda emojis.remove and put the emoji there. So this is how it looks. Emoji flies in, and we are removing them. It's fine, right? It's just everyone loves it. Your users will be happy. Your manager will give you a rise. It looks good. It looks good. So what is happening here? Any guesses? Yeah, speak aloud. They're firing on the same time. No, they're not. No, they're not. So the index is changing in the list. It's close. It's close. So what actually is happening, our list do not know that we are removing exactly that item. So we are removing item from the list, and the list is recomposed because there are other children in the list. So what we need to do, we need to inform the view to do not recompose children when the list is modified. So it's not, I don't know if list changing the index in that situation, maybe. But we just need to inform our list to do not recompose the childs. And to do that, we can use the key utility function. And this key utility function is a utility composable that is used to group or key a block of execution inside of the composition. It's a very easy function. It has just 2 parameters. One is just key, that type of any, and then we have block of composable. So now to our data class, we are adding the ID, which is string, and this ID will be just random UID. So now every emoji has the unique ID, and we'll use this ID and wrap the single emoji container with the key utility function. So now, whenever we are removing exactly like we were before also removing exactly that emoji, but now we are informing to do not recompose other emojis because the ID didn't change. So let's go now to check our layout inspector. We do not have those invisible items anymore. They are disappearing. And then on the left bottom, you can see the memory. And I couldn't reproduce those 200 megabytes. I could go to 120 maximum. And then, as you can see, we are going back to 95 as the beginning. So everything is nicely collected, and the memory is freed. And the animation looks correct. We do not have those weird changes in the emojis. So everything works. So the reason I'm saying you that is that because we have the production example with that, and we encounter this issue on the production at Tilt. So what we are doing during the streaming, every user can send some emojis to other users or the seller to show what they're feeling about the streaming. We are sending that to backend as our user emoji, converting that to our viewer emoji, and every viewer sees these emojis from left and right side of the screen. So then we have another user that is doing exactly the same, sending different emoji to the backend, and then it's converted to viewer emoji, and so on and so on. And you can end up with really thousands of emojis. And just quickly, how we are doing that in ViewModel, there's no magic there. We have the mutable state flow, and we have a set of pair here. One is the Unicode of the emoji, and the second one is the unique UID to use in the key utility function. Then we have the update viewers reactions, where we are deleting every pair when the animation ended. And in the composable, we are calling the viewers reactions, which is our list of emojis. And with this key utility function, we are displaying each emoji. And how it looks in production, as you can see on the left and right side of the screen, some emojis are popping in. This is the demo in our dev environment, so nothing crazy here, not thousands of users are sending, just me. So as you can see, we can send some emojis. There are some emojis that are coming from different users from the left and right side of the screen. So the key takeaways from this talk is that use Lambda version of modifiers when you have frequent changes of parameters. Use the key utility function when you do not want child to be recomposed when something changes. Always check the number of recompositions. Those 280 was quite big. And then remove the object from the state when it's no longer visible, because you do not want to have those ghost emojis there. And as a bonus, I can share with you that currently I'm building the particle emitter that is using exactly this technique. As you can see here, some examples. And I hope I will make it till the end of the year, some alpha version. So if you would like to see some updates, you can check my Twitter. It will be open source on GitHub. And another production example, we are using those particles to show when someone is buying something for a lot of money. There was those, sorry that this didn't in the loop. Let me do it again. You see those particles? It's like 2,000-3,000 of them floating around every time someone buys something for 100 pounds or more. And then it's another one. We are building currently the boosts, and the thing that is growing inside, this fog, color fog, it's also using particles. So the thing that is morphing inside, this is not one object. This is like 100 or 1,000 small objects that have really little changes in the offset. So it looks like it's morphing, but it's actually like 100 objects inside. And this is how it looks. It's also demo from the dev environment. We are using particles a lot, as you can see. So those investigations were quite important for us. And when you want the boost, you have another particles inside. So everything is sparkling, and we are sending a lot of particles in our system. If you would like to read about this, exactly the same title is in my article in Medium, and you have the QR code for it. Every code example that was shared right now during this talk is there in the articles as well, if you would like to follow. And last but not least, we are hiring lead backend engineer at Tilt. If you know someone, then please reach out to me on Twitter. We can talk about the company and how it works at Tilt. And thank you for listening.